So let's talk for a little bit about the problem of underproducing software quality. Now, we all know that users prefer to run software at a high quality level, and developers prefer to maintain software at a higher quality level. Nobody wants to be working in an open source software project where you're kind of staying ahead of things and releasing software at a quality level that makes things hard to change, hard to manage, hard to make progress. The problem in software is that we persistently release code at a lower quality level than either developers or users would prefer. And kind of the other side of that problem is that software developers who produce a lot of value in the form of a public good tend to be undercompensated. Now, there's a huge set of literature on why do we value public goods but underproduce public goods. And there's a bunch of ways to try to deal with the problem of, well, here's a public thing that people like, and we need more of it. And of course, the biggest way to deal with that problem is to, well, let's create some kind of an artificial property right in a public good. Let's apply copyrights, patents, that kind of laws to encourage the production of some public resource like software. And of course, that type of problem, or that type of approach tends to feed into all kinds of extra transaction costs and problems with restrictions on speech, restrictions on business models, competitive concerns. That the proprietary approach will only get you so far. Other people say, oh, well, let's just use open source as a complementary good to something that somebody does make money on. So, hey, if you give away some kind of a network service, or if you sell some kind of a network service, then you give away the software that's a complementary good to that. So you've lowered the total cost of the combined good, which is the service plus the software. Another great example is network cards and network card drivers. They're logical complementary goods. If you produce a network card, charge money for the network card, you give away the driver because A, that means that the operating systems do all the maintenance programming for keeping your driver up to date on new versions of the OS. And B, the total cost of ownership of your network card is lower because people who are running the right OS already have the right drivers. So artificial property and complementary goods are kind of like how we've been band-aiding along of dealing with the problem of underproduction of a public resource like software. But it's clearly not working. We're clearly dealing with an ever-increasing, how many went to the keynote? Okay, we're clearly dealing with an ever-increasing problem of lower quality software, people under-incentivized to produce the software at the quality level that we need. Now, I'd like to propose a new way of dealing with this problem of under-incentivization. And that is, let's look at the problem from the point of view not just of, I'm an open source developer, I want to get paid more to make better software. Let's also look at the problem from the point of view of the downstream user of that software. Let's say an engineering program manager at a company that's incorporating that software into a larger project. Now, from the point of view of that downstream user, what looks like a sustainability risk and a compensation risk from the developer point of view is an upstream dependency risk, and because of all the human factors and the complex dependency trees for modern software projects, it's extremely hard to quantify. You don't know. If you're building a substantial size software project that's pulling in open source from all over the internet, you don't know if you're going to have problems delivering on your project because the maintainer of your dependency's dependency is about to burn out or get a job working for a startup or something like that. As the program manager of a software project, you want to be able to quantify that risk and hedge that risk. Just like if you're General Mills shipping Cheerios, you can quantify and hedge your exposure to the oats futures market. If you're producing software, you should be able to quantify and hedge your risks of exposure to the software development process. So let's go over to the demo. All right, I am in the Pin Factory project, and what I'm going to do right now is I'm going to run a shell script that's going to launch the project. What this application is a very simple futures market that is directly tied to the status of a bug in a bug database. So if I'm developing software and I'm exposed to some kind of a risk because of a bug or an unaddressed issue in a software project that I depend on, then I want to be able to hedge that risk, and I want to be able to incentivize someone to fix what I need fixed. All right, let's see what my let's see if my demo holds together. Okay, so what I'm doing is I'm launching, in this case, a Docker container with the application running in it, and I'm launching 3 separate Firefox profiles for 3 separate local users. And hold on, do I have another copy running? Let me just kill something. All right, we're starting up the Postgres database in the container. And we started up 3 users. Oh, yes. Yes, please.
some development time to making sure that it will itself, enlist in fixing the bugs. So I mean, instead of buying the software, maybe necessarily, it will actually contribute to the upkeep of the software if it's using it. So if you get enough companies and you get enough good developers, they'll all sort of like attack the bugs in the software. So they'll be paid by the company that's using the software and integrating it will be paying the cost of upkeep of the software. So it's like the more people you have using it, the more you will find that there are people who have ability to contribute to the source.
Yes, exactly. And so yes, repeat the question. Okay, I'm going to summarize the question briefly, and that is, if an open source software project is used by a company, and that company is the downstream user of that project, then won't that company either assign one of their employees to work on that software project, or won't that company hire someone who's into that project or allow them to spend some of their work time and computing resources on that project? And the short answer is yes, this is an incredibly successful model, and it has been incredibly successful for certain projects. We've seen really good examples of projects like, say, Apache Cassandra, where you've got a bunch of large-scale users of databases, of large-scale NoSQL databases that get together, and they all have developers who are wearing their Apache hat some of the time, and they're wearing their corporate hat as a downstream user of one of those many Apache projects some of the time. So this has been the idea of, well, let's have employees contribute to it some of the time, has been very successful, especially for big, recognizable brand name projects. Unfortunately, today you get into situations where even a simple website can have many layers of dependencies. So I might say, I might go to build my project, and I'm pulling in open source code from 60, 70, 80 different repositories. Now, of course, people like to joke about Node.js for doing this. You see this huge scrolling by list of Node packages anytime you build something with NPM. But it's really, in a lot of ways, a positive trend. You've got not just Linux and Samba on my file server box, but now you've got software projects from many, many different sources all coming together to make your downstream project a success. And the answer to the question of, well, can't you manage your way around having your employees do it, is yes, you can do that for some projects. But realistically, you can't do that in today's environment where dependency trees are broad. You've got a lot of different projects that you're aware of. And dependency trees are deep. Each of the projects that you're depending on can also depend on others, going down many levels. So the transaction costs and the management burden for dealing with many different projects at once is something that means it's harder and harder to quantify your software risk. And thank you very much for asking a question. If anyone else has a question, please stick your hand up, and I'm happy to take questions in the middle of this. All right, great. So let's think about a real simple use case for futures markets in software bugs. and then I'll run through a demo on an actual bug that I pulled off of the live site. So, simplest possible use case is, let's say I have a blog, and all of a sudden I decide, well, I want emoji on my blog. So I check out the open source repository for the blog software package I use, and I see, hey, there's an issue on there for please support emoji. As a user, I buy a futures contract on that issue that will pay me in the event in the event that bug goes unfixed, and pay the other side of the contract in the event that it gets fixed by a certain date. Developer comes along and sees that offer out there in the market and says, hey, I know how to make this work. I'll add the emoji support. When that issue matures, the developer gets the money from the winning side of the futures contract, and I lose my money, but I get the feature, and I can have emoji on my blog now. Now, so far, this sounds a lot like an open source bounty model, right? Where you get onto one of these systems where you can put up money to get an open source person to do the feature that you want. The place where this is different from a bounty and has what we hope are some positive features over a straight bounty system is, in a bounty system, you've either got the extra transaction costs of figuring out which developer was responsible for fixing something, or you've got the friction of developers claiming issues in order to contend for a bounty. The place where this is really a problem is where you've got a bug that requires multiple skill sets to solve. So if I report a bug in a web application, and there's a problem in JavaScript and there's a problem in CSS, if it's on a conventional bounty system, somebody might figure out the JavaScript right away, but then they get stuck on the CSS. They don't want to disclose their JavaScript work because they're contending for a bounty on the whole thing. Meanwhile, someone else has figured out the CSS, they're stuck on the JavaScript, neither one of them ends up fixing the bug. So bounty systems tend to get stuck as people contend for being the one person to claim the bounty. Where futures are different is if that situation with the JavaScript and the CSS problem was in a futures market, as soon as you fix one side, you've got an incentive to disclose and share your partial work in order to increase the value of your position. So you can say, hey, I hold a futures contract in this. I did all this JavaScript work. It's totally nailed for the JavaScript. And if the CSS developer checks that out and it works except for their CSS, then they can buy out the JavaScript developer and share the reward. The end user and the project maintainer don't have to get involved. The overhead is a lot lower if you can trade the contracts freeform. So let's work through a simple example. Okay, in this example, I'm an end user of a project. I'm Adam. And Adam is going to look at the available issues in the market. And Adam has decided, let's see, which one of these issues does Adam really want to get fixed? Adam really wants toaster notifications. So there's a bug for adding a toaster notification when a new message becomes available. And by the way, this is a bug in Pin Factory itself. I want to add this feature for real. But in the demo, Adam says, hey, I want toaster notifications. So let's go through and look at the marketplace. Well, all right, there's no trading action on toaster notifications, but Adam wants this feature, so Adam will say, place an offer on this issue. Adam's going to put up 200 tokens. And in this case, Adam gets to decide how much the other side of the contract should put up. So Adam can say, well, I want to make whoever holds the other side of this contract put up 200 tokens of their own, so that we know somebody doesn't just come along and free ride for the rewards. So we know they have skin in the game. So Adam is going to say, I want the worker to put up 200. Adam is going to say fund, because they're funding a piece of work on the project. And Adam's going to say, let's have this mature on 21st March, earliest available maturity date. And now we can see the market fills in the details of the offer that Adam's making. The market says, if this issue is fixed on 21 March, you will lose your payment of 200 tokens. If this issue is unfixed, you will receive the contract payout, which reflects a transaction fee of 20 tokens. So there's a 10% fee in the market for resolving the contracts. We'll get back to the fees and how to avoid the fee in a little bit. So this is the offer that Adam wants to make. So Adam is going to say, place offer. And now we can see it shows up in Marketplace for this issue. And Adam has placed Adam has placed this one offer, and there are other offers available in the Marketplace. Okay, so this browser window is another session. I'm doing these with different Firefox profiles, by the way, so they're all Firefox browser, but they're completely separate sessions, which is really handy for multi-user demos. Here is Beth, and Beth is looking to write some software and make some money. So Beth is going to look at offers in the market. And here we go, add a toaster notification. Now, let's say Beth is really good at JavaScript and CSS and decides toaster notifications, I can make these work. So she's going to click accept offer. What accept offer does is it populates that same offer form that Adam filled out, but it's now populated with an offer that will take the other side of the futures contract. So in this case, if this issue is unfixed, you will lose your payment. So Beth's taking the other side of the deal. If this issue is fixed, you will receive the contract payout. Now, when Beth places her offer, there's a message at the top of the screen saying contract formed. So Beth now holds a contract on this issue. And when Beth goes to her contract page, there is a fixed contract of which Beth is the owner. Let's go back to Adam for just a second. Adam also holds a contract, but Adam holds the other side. So, any questions so far? Yes, in front.
Where is the worker supposed to get the initial tokens for in this example?
In every project that's onboarded, we populate the set of contributors with tokens that they're given as kind of their initial stake. So basically, the Pin Factory project is looking for open source projects to bring on, and these tokens are, for now, they're play money. And so what we do when we bring somebody on who wants to have their project hooked up to Pin Factory is we will hand out some tokens to people who show they have a record of committing to the project. And the project maintainer will also be able to hand out tokens to some of their key users. And for the stake problem, there are a lot of interesting ways for projects to make sure that every new developer comes in with a stake, but without just handing out tokens willy-nilly. We know how that goes. Okay, does that answer your question?
Somewhat.
Okay, thanks. All right, so 2 contracts are held, and it is now time to take a time jump. All right, we're going to time jump 15 days into the future. Now, what's happening inside the container here is that the database is being shut down, and it's being restarted as a child process of the fake time tool. So in our container test environment, we can jump time forward as much as we want. If we try to jump time backwards, then we might completely mess up our database integrity. So at the application level in the market, there's a functionality for jumping time into the future for doing demos, but you can't jump time backwards. All right, so our application is reconnected to our database, and here's our third user, Charles, and Charles is the project maintainer. Let's reload Charles here for a second, and you can see that from Charles's point of view, it's now the future, 22 March. And Charles has the ability to resolve contracts. All right, so what do you think? Did Beth write the toaster code? Come on, she nailed it, all right? Okay, Beth wrote the toaster code. And so Charles has already accepted Beth's pull request, and he's going to resolve the contract type as fixed. All right, so Charles gets his message that this contract has been resolved. So let's go back and see what things look like from Adam's point of view. Well, Adam doesn't hold any contracts anymore, but Adam has a message saying that his contract has been resolved, and Adam got 0 tokens from that. Here's Beth. Let's reload. Beth no longer has any contracts, but Beth has received a message saying that add a toaster notification was resolved, and Beth received 380 tokens. So let's summarize where those tokens came from. Adam put up 200. Beth put up 200. The profit for the winning developer was 200, and the fee that came back was 20. So 380 tokens is what Beth ended up receiving. All right, any questions so far? What happens if multiple people are bidding? What happens is that we can look at offers. Actually, there are no live offers on the market right now because they expired when we jumped time. Let's go look at the live site for just a second. All right, here's the live site where I'm logged in as myself. All right, so there are multiple offers in the marketplace, and offers can have different prices. So some user might say, I'm willing to put up 200 tokens to fix this issue if the developer also puts up 200 tokens. So in effect, they're offering to buy the unfixed side of that futures contract at a price of 0.5. Somebody else might make a better offer. So as the person who's clicking accept offer, you can choose offers to accept. So if someone else had gotten in before Beth and accepted that offer, then one person could end up holding the fixed side of Adam's original contract. But then another user might come along and make an offer on the same issue, and a different user takes the other side of that one. So there's no rule that says that only one developer can hold a contract on any one issue at a time. If people are collaborating, they might choose to split up the fixed side of that contract. Does that answer your question?
No, then the answer is, so I know people who will do this. They will sit around and wait until they bid down the contract to zero, and they get somebody who will volunteer to like work for them. In other words, if you don't have a union, everybody's an individual out there. You know, the big players have a lot more advantage over the individual than the individual developer. And they, you know, it's like, of course, and then how do you? But of course, the opposite side of that is the person who's like bidding zero because they want to do a project and they're trying to learn something. It's not going to necessarily. So how do you tell who's quality? How do you tell the quality of the developer against, you know, the risk? You know, you're risking, if you're bidding it down to zero, you're risking finding somebody who's being predictable. And if you're bidding, you're paying too much, you're, you know, paying too much. Anyway, so the question is, all those sort of issues, sort of like those grand sort of economic issues of like, you know, who's going to take the risk and is somebody really getting paid what they're worth are all sort of floating around in the background.
Yeah, that's a big issue, and one of the most persistent problems for trying to manage open source is what they're calling open source metrics. And so Linux Foundation, among other places, are trying to figure out, well, given what we know about the activity on this project, how do we know, is it good now, and how well can this development team respond to issues that they run into in the future? And so today, it's extremely difficult to tell, well, is this project just done by people who are looking for something to do and would do it for free? Is this project done by people who have other demands on their time and are probably going to be leaving soon? We don't know that kind of information right now looking at open source projects. And so the price signal that's sent by where are contracts on this project's issues trading feeds some information out of that project into the group of downstream users who are considering or already running it. Yes? Hold on, let's get you on mic here.
Okay. Yeah, I mean, the same sort of question arises. 30 years on Wall Street makes me think about this. Everything seems like a market, except kind of to the other fellow's point, particularly a futures market, as they all evolved and to some extent became more sophisticated, but they all started from a point of what are they doing? They're commoditizing something. And so it makes it relatively simple to understand the value. And, you know, that's where it then starts to, you know, sort of back pressure into the question of the other question, and that is, you know, how do you just establish value? How does anyone assess the value? All these kinds of questions. I mean, it's otherwise, you know, a totally interesting idea, but, and, you know, markets are now fairly easy to create in almost anything, but the question is, how do you get a market in the terms of buyers and sellers? And the easiest way has always been to have a rather simple product.
You know, it's a question of knowledge too, because I know from Node that there's a guy, Soros or some guy who's like contributed hundreds of fixes to like Node modules, and he was one of the guys. He's one of the original Node programmers, and it's like he fixes things immediately. He's got so many, you know, pulls and fixes that it's. I'd pay. That's the first person I'd go to figure. You know, but I don't know anybody else. You know, like. But that's because I use Node and I'm a developer. So but how does somebody who has like less knowledge than me make a decision about the quality of the bids that they're getting? You know, so it's a question of knowledge. It's a really complicated issue, really. You know. Yeah, that's why. Well, that's why you have to add sort of a system of like qualifications, like how many projects has somebody done, how have they done on it, what's the satisfaction level of, you know. Eventually, you have to build that into the system too. So.
Right. So we're looking at the problem from the maintainer's point of view, and the downstream user's point of view, and the point of view of the developer who needs to be incentivized. And so one big problem that people bring up with this is, well, how do you know that the maintainer is going to resolve these issues correctly, right? So would a maintainer be willing to close an issue, either say, no, this doesn't fix it, and result in a futures contract closing with the wrong status and the wrong person getting paid? Or might a maintainer not cooperate in the process at all? And the real answer has to include the maintainer's decision to evaluate the code as it comes in a fair and independent way. Because don't forget that the owner of the futures contract is completely decoupled from whoever might actually be doing the work. If you know that there's some extremely dedicated developer out there who's likely to fix something for their own reasons, then is it possible that the fixed side of that contract is taken by someone who's purely front-running? And so there's going to be a situation where the owner of the contract and the person who profits from the movement in the contract is different from the person who's done most of the work. So in that case, kind of the degenerate case of bug futures, it turns into a simple prediction market where people are just just trading on whether or not a certain thing will happen, and not so much an incentivization market. So prediction markets and incentivization markets are related. You can use a lot of the same code for both, but when you've got a true incentivization market, you've got more of the money feeding through to the people who do the work. And I agree that it's extremely difficult to tell, especially in a large developer population, who might be the appropriate person to do the work, which is why we take the almost radical step of decoupling and not having that assignment bit in the system. Yes. Hold on, one more up front.
What happens if a bug gets reopened by the maintainer?
What happens if a bug gets reopened by the maintainer? So the status that matters for resolving the contract is what is the status of this bug on the maturity date of this contract. So let's say we've got this toaster, the toaster bug with a maturity date of March 21st. And so somebody codes up an awesome implementation of toaster notifications, and it gets accepted, and then it turns out that the toaster notifications put way too much load on the back end, and every user who turns on toaster notifications has to turn them off because they're clobbering their server. And so the project maintainer decides to back out the toaster notifications. Well, if they do that, then that bug can be reopened, and the status is unfixed as of the closing date of the contract. One of the things that this system ends up requiring is good hygiene and updates in the bug tracker and helping it accurately reflect what's there in the code. Does that answer the question?
But could a malicious maintainer close something, then reopen it right after the close date?
Could a malicious maintainer can do anything, right? And so if a project has an untrustworthy maintainer, somebody who's not going to close their bugs either accurately or in a timely way, then a market can't emerge on that. So it's kind of like if you tried to do oil futures, but that one big valve in Cushing, Oklahoma was not metering correctly when the oil's actually delivered. The market can't happen without the accurate and up-to-date status in the bug tracker. All right, any more questions? Yes. Hold on a second.
So how would licensing work in this case? Can someone putting in for example, let's say there's a fix for a time-critical or operation-critical piece of software, but they want to own that fix. They don't want anyone else to have it. How would a maintainer of a project make sure that something like that doesn't happen in their project?
So that is a piece of project governance that the maintainer is going to check before putting that bug into the final closed state. And so if a project requires, say, a copyright assignment or a CLA or a contributor license agreement or anything like that in order to put a bug into a final closed state, then that's something that the maintainer would have to check before they before they mark it as fixed. And the reason why we've got fixed and unfixed here instead of some of the other statuses that people like to use in their bug tracking systems is for each project we hook up to this, we have to designate which states in the bug tracker are to be closed as fixed and which are to be closed as unfixed. There might be a project, for example, where they accept code and commit it to master, but they don't put the project into, or they don't put that bug into its last state until it's deployed or something. So in that case, for a project like that, we would say the fixed in the market equals deployed in the issue tracker. So project governance doesn't change, but there does have to be that mapping of this state in project workflow maps to the fixed state in the market. So back to the question of maintainers and putting work on the maintainer to resolve an issue. In a lot of cases, it's going to be very clear to both holders of both sides of the contract when an issue is either fixed or it's extremely likely to be signed off as fixed by the maturity date. So one of the things that a developer can do if the fix is up there, it's gotten positive reactions, it just hasn't been merged and closed yet. One of the things the developer can do is say, all right, I hold fixed on this. I'm willing to also buy unfixed at a very low price, of course. I'm willing to buy some shares of unfixed to offset my position. Now, the user is going to be looking at their view of the market and see, oh, this thing's fixed or as good as fixed, and I don't want to wait to I don't want to wait for the future to get all the way to zero. So I'll take that offer. I'll get back maybe 5 tokens of the 100 that I put up. But that way, the developer gets paid right away. The user gets a little bit of their money back. And because those two futures contracts offset each other, there's nothing left for the project maintainer to be forced to resolve. So the project maintainer doesn't have to go in and pronounce judgment on something when the user and the developer agreed to resolve that futures contract by consensus. Another thing that can happen is if you're a maintainer or a sub-maintainer taking on some kind of a role within a project, you can buy out some of those developers so that they aren't stuck holding a position and waiting for their money. You can buy them out and hold them to maturity. All right. Any more questions? I think we're actually a couple minutes over time. Was this till 12:15? So, all right. And if you would like an account on the live system, or you'd like to hook up any of your open source projects to it to try it out in play money mode, please come see me.